Hi everyone, welcome to lecture number 18, which is cloning a linked list. Cloning a single linked list. See, whatever linked list we saw, like if we consider single linked list, we have a struct and we have a node, and this node we have only two things, right? One is value and one is next pointer, which will be pointing to star node. Right? But now in this problem statement we'll also have another field called random, which is also a star node. Okay, so let me explain with a problem so that you will understand it. Let's say this is a linked list. Okay, but there is a small change here. Here the next points to here, the next points to here, the next points to the next points to here, but there is another thing which is random, which can point to any of the nodes. So that means this can point to this particular node, this can point to this particular node, or they just remain nil. That means they are not pointed to anything. This can point this one, and this can point to this one, and this can simply point to nil. Okay, so what is our task? Our main task is to clone this particular linked list. Okay, so that means we should create a new linked list with the same structure. So it should contain the same structure but with different nodes. That means the node which we create should be new. You should not just directly send the old one. You should send a new linked list, new nodes. So you will send a new linked list with the new nodes. Okay, but how you can solve this problem? See, cloning a linked list is not a matter, right? So let's say first we'll solve the first problem of this question. First we'll solve all the dot next one. That means first we'll solve how we can clone this particular linked list. Okay, and then we'll go to how we can solve the random pointer thing. Okay, so first we will clone linear single linked list. Okay, so let's say we'll simply create a dummy pointer. That means you'll have a dummy head here and another thing which is pointing here, a dummy pointer. Okay, here the node value is -1. You can it's your wish, you can keep anything. And now we'll start a pointer at this particular node. Okay, and now we'll just simply create a new node with it. So now we'll simply attach this and we'll create a new node, 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 and we'll create a new node. So it's around 1 2 3 4 5 6. Did I create 6? No, 1 left over. Okay, so these are 6 nodes. These are done. But how do you know that, let's say now this particular pointer is pointing to this node, this particular thing should point to this, but there is no track, right? See, there is no track which is the old, like these mappings are present in old linked list, not the new one. You cannot simply take the random pointer and random value from here, and you can't keep the random you can't set the random to the old linked list because everything should be new. So how you can solve it? One is, let's say there are two different approaches. First we'll see approach 1. Okay, we'll see approach 1. The space may not be concise, but yeah, it will fit here. So let's say the approach 1 is using space. Okay, how we can solve this problem? So now first what you do is, when you are creating new lists, here you are creating new lists, here you are new nodes. If you are creating a new node here, new node here, new node here, let's mark these nodes first. It's just for example, it's not really marking out. Let's say this is A, this is B, this is C, this is D, this is E, and this is F. Okay, and now when you are cloning this, let's say for example this is A, this is B, this is C, this is D, this is E, and this is F. So capitals are new and the smaller are old one. Okay, right, now what we can do is we can simply create a map which is of type star node to star node. Okay, so here what you can do is you can map the old values with the new values, right? So what you can do, you'll create a map here which will map A to capital A, B to capital B, C to capital C, and so on. Okay, so now let's see how we are going to solve this problem. Now we have created a map which has a mapping of old to new, right? So now you'll place a pointer here and you'll place a pointer here. You have created already this particular list, right? The smaller one, so there is no issue. The linear list is created. The only thing you need to do now is pointing the random values, right? So now you will start your second iteration. So first iteration, you have completed your entire linear list, and now the second one is you need to fill the random pointers. Okay, so how you are going to fill? Let's say you are at position A, here also you are at position A. So now here you should point this particular A to B, right? No, first in the old it's there, right? A is pointing to B. So first, if here there is some pointer which is pointing to some value, it is not nil, right? So you need to point this random pointer to some other node, right? But how you will get it? So first you will take the random pointer from here. So simply you can take A dot random. Okay, now you'll get the A dot random, so you'll get which node it is pointed to, which is B, right? So this is simply B. Okay, so now you will search this particular node in this thing, right? In this map you'll simply call this B, right? So now you will get the new B. That's it, right? We have mapped the old B's with the new B's, right? So now that means you can simply place your A dot random with simply map of A dot random. Okay, you should only do this if A dot random is not equals to nil, right? In this way you can solve this problem. So you have two loops. You can say it's an order of n time complexity. And what is your space? So space also you can say that how many nodes you have, that much node it will occupy. So height of the tree, so you can consider O log n. That's what height of the tree, right? So now this is the total space taken to solve this problem. But now, oh, I guess this is order of n. My bad, this is order of n. We are taking n keys, right? So now this takes order of n time complexity and order of time complexity. Can we still do something to reduce the space complexity? Yes, there is another approach. Let's discuss the approach 2. So this is approach 1 and we'll discuss an approach 2. This fine, this color is fine. So let's say this is approach 2. How you will solve this problem? See, let's take a new list so that you'll understand it better. It's the same list I'll take. Okay, 3 nodes and 3 nodes. Yeah, see, it points to here, some random pointer here, some random pointer here, some random pointer here. Okay, now if you see, let's say if you find let's say you will create a linear list. It is simple. You will create a linear list. It is common in both the approaches, but now how you will fill the random values here is different. See, let's say this is an old list and there is, let's say this is a new list, so which is a newly formed one. If you see it, you can notice a pattern. See, let's say this is the first node is pointing to this particular node. If in this old list from the start, if hear my words, from the start, if this is x distance away, then that means in the new list also the one which we are pointing will be x distance from here. That's it, right? So what's your basic intuition behind it? It's just distance, right? So first you need to find at which index you'll get this particular random pointer. If your random pointer is not equals to nil, find index in the old list. Okay, and now you can simply, what you can do is you can iterate these many indexes in your new list and point current node dot random to the final node. That's it, right? It's that simple. See, let's say if you are let's say it's x distance away, which is one node, right? So now you can keep a current pointer at the start of the list, and you can simply hop one position. So that means you'll get to this position, which is b, right? So now you can simply a dot random will point to simple b. It's that easy by index approach. But can we guess the time complexity? Yes, it's a little bit higher. Why? Because for every node, let's say for this particular node, we are traversing the entire thing from the start, right? And for this also it's the same. Like if you are here, you need to traverse all this. So it's basically order of n square. But if you see in the LeetCode, this problem is marked as hard, if I'm not wrong, and number of nodes are given as 500. So these are less, right? So 500 into 500 will come still below the time limit exceeded, right? Will below the TLE. Sorry, below the time limit. So it works fine. So there is no issue. So here the space is reduced to order of 1. So still there is a space for creating a linked list, because that's what we say, that was they are also expecting. But other than this, we are optimizing the order of n other space, right? So this entire space, the map space, we have optimized, we have removed it. So there is only order of n which is creating the new linked list, right? I hope you got the basic intuition beside behind this problem. If you have any doubts, please make sure to comment. I'll be replying there. Yeah, that's it. So let's jump into our coding session. So let's see how we can write code for this particular problem. So we'll start at this function copy random list, which will accept a node and will return the new node. First we'll create a dummy node, which we discussed. We'll simply create a random nil, next nil, and value -1. So there is a dummy pointer which will be pointed to dummy head, and a current pointer will be head. Okay. So now until current pointer is not nil, we'll simply keep on creating the nodes, right? Which means the linear list. We'll first construct the single linear list, and then we'll take care of random pointers, right? See, we can create here, and next the dummy pointer will be pointed to dummy head dot next. That means the first node in the new linked list, and current pointer dot which will point to head, which is a old linked list head. And until current pointer is not equals to nil, if current, which we discussed, if the current pointer dot random is not equals to nil, then only you need to make these changes, right? So now the index, this is a second approach, so you can also write in first approach if you want, but this is the most optimized approach, right? So I'm discussing only that one. And index will be like find position from the start. You need to find the first the random position, right, from the starting in the old list. So that's what I'm doing here. Find position from start head and current dot random. So let's see this function, which is find position from start. You'll keep index as 0, current pointer as head, and until current pointer will equals to a search node, which is a random node, and you'll increment the index and simply you'll return your index. So that was about this particular thing. Okay, now you need to get the new you need to get the random which you got, that means here you will get some index, right? With this index, at this index there will be a node in the new list, right? That we need to find. To get that particular thing, I wrote a different function, get random pointer node, which will accept the new list and an index. So what does this do? They simply keep current pointer equals head, and this will give which node is present at that particular index. So this will be returned by get random pointer node, and we'll save here. And what we can do, we can simply dummy pointer dot random, you'll point it to random pointer node. That's it. And after that you'll simply increment your current pointer and your dummy pointer, and you'll simply return your dummy head dot next, because the first one is just a garbage value, right? This is not required.